Alright, in this video we're going to talk about a G83 Peck drilling can cycle. And we're going to be drilling the minor diameter of a 3/8 tap. So we need to find out what size drill to use. So looking at our drill chart here, we have a minor diameter. And we have two columns, a min and a max, that they recommend using. So we need to be between 307 and 321. So that's 307 thousandths and 321 thousandths. So a 5/16 drill would be a 312 thousandths, and that's a pretty standard minor diameter drill used for 3/8 taps. So let's use that in our G83 can cycle. And let's talk about a G83 can cycle. A G83 can cycle is a Peck drilling cycle. And the format in the program is very similar to a G81, which we covered in the previous video. Only thing that we add on the line of a G83 can cycle is a Q value, which is the pecking distance. Okay, so let's take a look at the simulation. The drill actually rapids to 100 thousandths above the part, and that is controlled by the R value in the G83 can cycle. And then the Q value is the pecking distance. And remember, between holes, the distance that it retracts can either be 100 thousandths above the part, or determined by the R value, or the Z value before we get into the can cycle. So that's determined by a G98 or a G99 in front of that can cycle. Alright, so we're drilling a 5/16 minor diameter hole, and we're drilling all the way through this 1-inch thick part, and then we're going to be tapping it a 3/8 tap. But first of all, let's take a look at the code, and we're going to add it to our existing program. Alright, so we've been building this program. We started with face milling, and then in the previous video we added the center drill operation, the G81 can cycle. And so we're going to continue to build this same program, and each time we're just going to add messages at the top of the program so that we know by looking at the top of the program alone what tools are going to be used down inside the program. You know, as you start building larger and larger programs, you want to make sure that you can see what tools are used in one glance. Okay, so let's go ahead and make a space, and we're going to add tool 6, and this is good for the operator and probably also good for ourselves. So call this a drill, and we're done there. Then we're going to hand write this, but we're going to take advantage of the cut and paste option in the editing software. So right here I'm going to separate some lines. We want to finish this off with a G90 and then an M1 optional stop. So that completes the center drill operation. The spindle is now in the home position, and everything is turned off, and we're ready to make a tool change to tool number 6, where we're picking up the drill. So what I'm going to do is copy this whole section here, copy, paste. So now I have two center drilling operations, and I'm just going to do a little editing here. So first of all, I'm going to change the description here. So that's going to be Peck drill minor diameter, and we can even say 0.312 minor diameter. Okay, then it's going to be tool 6, M6. As soon as you do that, always make sure that you change the H6. Anytime you do a tool change, make sure you follow it with H. That almost needs to be a simultaneous thing. Okay, you don't want to forget that, because you don't want to read in a different offset. Most likely the center drilling offset or tool length offset is going to be shorter, and you're going to have a crash. Okay, so we want to take a look at the spindle speed. That's going to be a little bit fast. We're drilling some mild steel, but the way you calculate that is bring up your calculator and we're going to use a service foot of 45. We have a high-speed cobalt drill here that we're using. So the service foot rating for steel is probably pretty close to 45. We're going to multiply that times a constant, which is 3.82. Okay, then you do equal. And then you can divide that by the diameter of the drill. Okay, so that equals 550. So that's going to be our spindle speed. So that's S 550. All right, so that's done. And then all we have to do is change a couple of parameters. Obviously we have a G81 and that needs to be a G83. So that turns it into a pecking cycle. Then the depth is going to be a minus 1 inch 125. Okay, our part is 1 inch thick. And so an extra 1/8 of an inch is going to allow us to break through all the way through that material. Then the only other thing we have to do is add 125 thousandths Peck to that line, and the feed rate we'll just go ahead and leave at 2 inches per minute. So we already have our X and Y for our first hole right here when we do our rapid approach, and then inside the G83 can cycle are the additional 3 hole locations. Okay, and then again we want to cancel the can cycle with a G80, turn off the spindle, turn off the coolant, hole mount the Z-axis, and then put the machine back in G90 mode. Okay, now I have this space in between here, and then I have this G28Y0. I'm going to leave that here, and we're going to squeeze another operation in between these two lines. That's going to be our tapping cycle, and that is going to be our next video. So I hope this makes sense. Every time you make a edit, make sure that you hit save. See you in the next video.